Okay, so welcome. This is week number 2, summer 2020 twice. Um, this lecture will cover chapter 3, which is one more than 2, one less than 4. Um, so if you look on, where's my notes? There's my notes. Where's my PowerPoint? Here's my PowerPoint. Here we go. Holly gave me this PowerPoint today, and it has a little bit of stuff in it that's we'll just view it. But she's making these to go with the textbook for the use of instructors to use during their teaching. Um, so anyway, on page, I got it written in here in my other notes, page 64 of the 6th edition, you'll see that these are the learning objectives from chapter 3. You should be able to access and use MATLAB's help feature. Very, very useful, and you can use that on the test. A variety of common mathematical functions, trigonometry, statistical and data analysis functions, random numbers, complex numbers, the limits of MATLAB, and special values and functions built into MATLAB. If you want to review those, they're all on page 64. Um, I'm going to hide this here because we'll be bringing it back up in a little bit. Vast majority of engineering stuff requires mathematical functions, adding, subtracting, multiplying, dividing, logarithms, trigonometric functions, statistical analysis. Oh dang! I wish I had that email. Oh man, that'd been so cool to do today. Oh, well, I'll bring it up on chapter 5, 2 weeks. We just did a run on a pipeline in California, and they pulled a pig out of the pipe yesterday, and uh, last night actually they found 6 areas of the pipe that was 60% corroded through it, and it was done in MATLAB with plotting features, and it'd be really cool to show that as a real world application of MATLAB. Anyway, back to the real world over here now. We're going to use this matrix here today, so that's why I've pre-built it so I don't have to build another one. So MATLAB has many built-in functions for use for your for calculations, for display of your text formats, plots. I mean, there's more you can do in MATLAB than I even know. I mean, I haven't even scratched the surface of the things that MATLAB will do. But for this chapter, we're just going to cover some of the computational stuff that MATLAB does. Some of these things I already did last week. If you remember, I did the square root, I think. So the square root of 5, very simple. And if we, I don't know what happened if we do a square root of x. Oh, there you go, a whole bunch of imaginary numbers. Um, but the square root will take either a scalar or a vector or matrix as an input. Um, uh, yeah, so square root was one that we've covered. Another, I don't, some of your functions, built-in functions, would you quit squeaking? That's noisy. Require more than one input, and like size we'll cover in a second here, tells you how many rows and columns there are in a vector or matrix. Um, but this one has 2 outputs, not 2 inputs. This is not a good example for 2 inputs, but you can do 2 inputs. So we'll go x and 2 and see what that returns to us. 4. Well, that's not very useful because it's a 4 by 4. Let's add another row here, and oh, too many, not enough. We'll back up, dude, back up. Come on, oh, come on. This isn't rocket science, it's MATLAB. This is easy stuff. So 4 there, and if we go 1 should be a 5. So 1 gives you a number of rows, 2 is the number of columns. But the thing with size is you can assign that to 2 variables. So assign the output, and what it does is it will assign to the first variable the number of rows, and to the second variable the number of columns. Uh, rows is usually not spelled with an X. Um, so this is very useful when we get into doing loops. If you're going to do a loop for a known amount of times based off of data that's input, you want to know how many data points there are in either rows or columns. And so by doing this, then you can pull that out, and you know, okay, well, I got to run this many times. And you know, as I demonstrated earlier too, if you do max value and location, again, we'll do the location. Now that we're doing that on a matrix, what it's going to return is two variables. The max value will be a vector of maximum values for each column, and the location is which row they are located in. So that's not very good. 1, 2, 3, 7, 11, 5, and 21. Okay, well, I was looking for 3s. This number down here, but this is which row? 3, 3, and 5, 5. So there's your maximum values. And then, you know, obviously it's same with min. When we get into chapter 6, you'll learn how to write your own functions to return however many variables you want. Stop me if I'm going too slow. Oh yeah, stop me if I'm going too slow, if I'm going too fast. You know, you can like nest your variables together. If we have this 1 to 10 and do a sine of theta. Okay, let's assign it to a variable here, y equals sine of theta, and we'll hide that. So this is one place where I disagree with the book, but this is just my personal preference. I personally, like I say, I'm a lazy typist. If I can get away from typing extra letters, I'll do the nest. That's not right, you idiot. Yeah. I mean, you can do that by doing it all in one set. I forget which page that's on, but it says that in their mind, it's clear if you break it up into steps like this, which it possibly could, but there are times where nesting, I think, is better. I'm not going to grade you one way or the other. If you like nesting, nest it. If you don't want to nest them, don't nest them. I'm easy to get along with as long as I get things my own way. Okay, any questions on that? Anybody more confused now than before this class or this lecture started? No? Okay, cool. So the online help inside of MATLAB, I think I covered this last week too, is just type help with the name of the function that you want help with. If you do help, it pulls this up, which is just a brief snippet inside of the command window. You can also get to documentation for that function, which will open this window up, which gives you a little more in-depth explanation on the function. But if you want that first, rather than going through that, you can just do doc plot, and that'll bring that up without having to go through the other extra step. Like I say, this is allowed during the exam. It'd be kind of hard to stop you from doing it, unless somebody's sitting there watching you work and seen you do it and slap you with a wire brush if you did it. That wouldn't be nice, so I wouldn't do that. So the help is available. The reason I use plot for an example is because I use it quite often just to remember what all this stuff is right here, because I only have 2 functioning brain cells and I forget a lot. Okay, so now we get into the common, there's a whole bunch of just common common computations. So these are some of the common functions that are in MATLAB. So you got the absolute value, the square root, the nth root, which is allow you to take cube root, fourth root, however many, whatever root you want. You just put that in as the n value. The sign returns whether it's positive, negative. Remnant tells you how much is left over if you divide x by y. This one here is one that students, ooh, hey, that moved, cool. The XP. I don't know how many times I've seen students try to do, instead of exp of x, try and do e raised to the x, because that's the way it's written in the equation, and it just, and then they get an error because e is undefined, and so they struggle. Just remember to do the e to the x is exp. Here's another one. A lot of students think that log x is the log base 10. Well, it's, I don't understand how hard is it to do ln instead of log, but log x is the natural log, whereas log 10 is the log base 10, and also log 2 is log base 2. Roundings. You get the round, which rounds to the nearest integer. Then this one will tell you the nearest specified digit, decimal digit. Fix rounds to the nearest integer towards 0. Floor goes to the negative infinity. That word towards negative infinity, and ceiling goes up. I've used ceiling a lot, floor occasionally. I don't think I've ever used fixed or fix. Some more here is factor. If you want to find what the factors of a number are, you can do that. Greatest common denominator, least common denominator. Rational represents it as a fraction. Factorial. This one you will be using in coming homework assignments. When we get into the no, not Fibonacci. Anyway, when we get into loops, while loops, for loops, there are several equations that have that in there. And seek choose, it tells you how many possible combinations there are in a pool of n, and like if you got 100 people, how many groups of 3 can you make? Oh, look at, okay, I was off by 10. I don't know that I've ever used that one outside of this textbook. Primes tells you how many prime numbers there are from 0 to that number. Is prime, we'll check to see if it's prime. All of these are in your textbook if you want to go through. I'm just going to hit the ones that we'll be using. Degrees to radians and radians to degrees converts obviously from degrees to radians, or you can multiply by pi over 180, and here you can divide by 180 or multiply by 180 divided by pi. Your basic, these three, actually these four, even, well, I don't know if that one matters, but these four, three here, 4 here, 3 here are in radians, and if you got degrees, you add a d to the end. So max, and here's the max min, assigned to 2 variables. Mean, median, mode. Median is average. The median is I think you line them all up together and you find one that's in the middle. The mode is the one that repeats the most within the vector. Sum adds them all up. Product multiplies them all together. Sum is a cumulative addition going down each column. So if this is your input, you have 1 plus 2 is 3, 3, 4, 5, 9, 3, 6 is 9, and it would just keep going depending on the size of your matrix, and the same with the product. Sort, if you do a sort, be it obviously it makes no sense to sort a scalar because the scalar sorted is going to be the same scalar, but I would probably do it because I'm that stupid. I mean, I'm that gullible. I don't know. Yeah, okay, I'm trying not to offend anybody. That's all directed at me. If you put a vector in there, it'll sort it from smallest to greatest. If you put a matrix in there, it'll sort each column from smallest to greatest going down. And if you want it going from greatest to lowest, yeah, descend as a format at the end in there. But if you want to sort an entire row, if you've got like data for a person going across there and you want to sort that whole row with respect to the other rows, use sort rows. And the X would be which column you'd be sorting by. So if you do 1, it's going to sort by the first column. If you do a 4, it'll go by the fourth column, going from least to greatest. If you want to go from greatest to least, there's 2 ways you can do that. Oh, this one just goes for the first row. This one is the one where you can get it to go to the fourth. And if you want it to go descending, you'd put a comma and in double quotation marks descend. Or if you want to do it a lot quicker than that, just put in a negative n. So if you want it going greatest to least, put in -4. We'll go sort the fourth row down. Am I boring you guys? Put you all to sleep?
No, not yet.
Okay. So here's determining the size of your array. The size one I already did is returns the rows and columns, and if you can do it to output to 2 variables. This chapter is really boring, I tell you. Assign it to 2 variables, you'll get the rows and the columns. Height tells you the number of rows, width tells you how many columns, length gives you the largest dimension of the group, and the numal is the number of elements within the array or matrix.
Quick clarification question.
Sure.
An array is just a matrix, but not being used for a mathematical purpose. Is that correct?
Well, okay, the way she's defining array in here is any vector or matrix that has greater than 1 element. So it could have
Okay.
multiple rows, multiple columns. If there's just a single element in there, then it's classified as a scalar. In previous texts, a vector or array was either a single column or a single row, and a matrix was multiples. But in the 6th edition, we've changed that and gone to an array.
Okay. Thank you.
Yep, it's confusing to me too. So standard deviation and variance. This is all statistical stuff. Your bell curve for standard deviation. Most of your data points will fall within 1 or 2 standard deviations of the norm. Here the average was 50, so within 1 or 2 is going to be your standard deviation. There is ooh, let's put this up here for a minute. Let's say that we wanted to find the standard deviation of my matrix up here, and this happened. This is a problem in the homework that a lot of students, I'd hate to say get wrong, but there's an issue with it. So if we look for the standard deviation, because I got those in all capital letters, it does not overwrite my function of that matrix. It will return a column of the standard deviation of each column. But if I wanted to find out what the standard deviation of the entire matrix is, the students will take the STD of the STD. Now, STD of the STD of X. There we go. Now, if this was the mean or a sum, if you wanted to add up all of these, you could do, a sum of the sum of X. because the first sum will, this sum will return a vector of the sum for each column, whereas if you sum up the sum of them, it gives you a total for the entire matrix. The same for the max, the min, the average, most of your things. But if you take the standard deviation of the standard deviation, okay, we see this is saying it's 2.18, but what this is a standard deviation of this vector of the results of the standard deviation. To get the standard deviation of the entire matrix, one way to do that is to convert that matrix into a column vector by putting a semicolon inside of parentheses. This takes this vector or matrix and turns it into a column vector. And now when you take the standard deviation of the standard deviation, you can see they're not the same. Wow, I stunned you guys into silence. So anyway, just keep that in mind when that problem comes up. Random numbers. So there's two types of random numbers that we deal with in here. Is the rand n and the rand n, which is the Gaussian random numbers. I don't think she shows here. So if you're looking for a specific range of numbers, so what? So the rand n, yes. Oops. Gives you a uniform random set of random numbers between the value of 0 and 1. So we can prove that by saying y equals, and again, this is one of those that there's an A in rand. If you put in a single value, it will create a square matrix. But if you want a vector, you have to put two, the first one being the row, second one's column. That's the default format, is row by column. So this, you'll notice here that these are all numbers. I'm going to transpose that so we can see them all. They're all between 0 and 1. Now let's say we want to, let's say, make it from 0 to 5. So we'll multiply this by 5. So now they're all between 0 and 5. Well, let's say we want to go between 0, or not 0, let's say 4 and 16. So between 4 and 16 is 12 digits, right? And then we'll add our smallest number, which was 4. So this is a difference between the maximum and minimum, the 4 and 16, and then we add the smallest number to it. And now these don't do that. These should all be between 4 and 16. Wow, that's cool. Say, yeah, that's cool. Okay, don't say that's cool. I'll just think it in my head. Okay, and then the Gaussian is a a set of numbers in a bell curve type distribution. You can specify a mean and a median, not a median, but the mean and the standard deviation. I don't want P. Rand n, again, rows and columns. And to get a specific standard deviation, let's say we want to deviate by 3, multiply it by the standard deviation, and then if we want to have an average of about 65, and we can prove that this works without looking at it by doing a mean of y and standard deviation of y. And that should be the mean should be about 65. It's not going to be exactly 65, and the standard deviation should be about 3. So these are in the textbook. I don't expect you to remember this. I mean, you can write it down right now if you want, but it is in the textbook. I could look up the page number, but it's in there somewhere. Um, I'm guessing somewhere around table 313. Uh, okay, complex numbers. Oops. Y'all know what complex numbers is. That's when you take a square root of a negative number, you get a complex number with a real portion and an imaginary portion. Um, so if you do the ABS on a complex number, it returns basically the radius. If you were to plot these in a polar coordinate system, so ABS would give you the radius, where angle would give you the angle for the polar coordinates. There's two ways to create a complex number. You can use the complex function. The first number is the real, the second one is the imaginary part of it. Or if you're lazy, come on, get back there. You could do just 3 plus 2 times I. Will give you the same thing. I don't know, this probably looks more professional, but either way will get you to the same place. Real returns the real portion of your imaginary number. Imaginary gives you the imaginary. Is real tells you whether it's real or imaginary. And conj gives you the complex conjugate. And then here's your limits in MATLAB. 10 to the 308 and minus 308. Largest possible integer is, it looks like my income for last year. Oh no, wait, that's how much taxes I paid last year. Was that hundreds, thousands, millions, billions? 2.147 billion, and then the same on the minus side. And then finally, special characters, pi, I, and j. Now, I and j are imaginary numbers, as I just proved in MATLAB over here. Oops, not SolidWorks, MATLAB. SolidWorks is going to be open up here in a second. Sorry for that. But if you're an imbecile, if you're like me, from the old days of when I was taking programming languages, I and j were always the index characters variable for loops. For a for loop, for a while loop, I always used I, j, and k. If there's any machinists out there, you'll also be you should be know or might be familiar with the fact that I, j, and k are in your G code to when you're doing a circular pass. It gives you the distance in the I, x, y, and z locations for the center point for your radius. Oh man, I just showed my age there. Yeah, so infinity means just a number that, calculate by 0. NaN is not a number. Clock tells you current time, date tells you current time, and EPS is a distance between one and the next larger double precision floating point number. Wow, I think I've used that never. I didn't even know it existed. So there's all the functions and stuff in this chapter. I'm sure you've probably, I think the practice exercises was already due for this. So you should have gone through the book. I don't know, do you want me to do these lessons before the practice exercises or after? What's more gooder for you people? I like Tuesday nights, but I can adjust. And they will get more exciting as we go along. This was just a boring chapter.
I think it helped to go through them before, just because I struggle a little bit more than I feel some other people are.
I can do that when I'd have to get. Hang on, let's look at the calendar here.
I'd agree. I'd like to go over it before, but Tuesday nights work best for me could we adjust the due dates possibly to like Wednesday nights or Thursday nights
Um,
instead of the Sunday?
I could do that, but then I can't. I guess I could push off the homework a little bit. Um, I could make the practice exercises due Wednesday and the homework due on Friday. Because
Yeah,
I think
that'd be great.
it would be helpful to go through this before you're struggling through the practice exercises. Um, okay, well, I mean, it takes a lot of effort for me to change the due dates. I mean, seriously, I mean, I have to take this and drag it all the way over there. You know how exhausting that is? Man, oh man, I gotta go take a rest.
We appreciate your hard work and dedication to this class.
Yeah. Oh, but see now, look at that. The end of the month, I can't just scroll down. I have to come all the way up here and hit that button to get to the next month. Sheesh, the things I do for you guys, I swear. Do you want the quizzes moved too? Is anybody even doing the quizzes? I mean, I got no problem moving it. I'm going to leave the. Oh wait, that's a problem though. That on there because this exam's already scheduled for this date, and I don't want to have the homework due after the exam. Um, maybe chapter 5. Maybe we'll hold a special session. You guys okay to meet one Sunday night before the exam?
I'd be fine with that.
Okay, because I really
Yeah, I
do,
think that'd be fine.
I don't want to move this. I mean, I can move these to Monday, and we can meet Sunday night, and we can make that one an extra special long one because generally for the first exam, what I've done for the previous 100 years was on the first exam I work an exam as an example. Um, maybe I'll do that on the Tuesday before or Thursday before as an optional. That's what I'll do. Is that Thursday I'll work an exam as an example of what to be expecting, um, and then yeah, because you got definitely you want to have a lecture on chapter 6 because chapter 6, um, and yeah,
Do you
chap
have any practice exams?
I do.
Okay.
I usually
Like,
what I've done in the past is like I say on the Thursday before the exam I actually perform the exam online, record it. I give you guys a copy of it as I'm going through it so you can follow. Um, and then I also give you another exam that I don't work through. Um, and here's another one of those that's a problem because the exam too. And then after that, it gets crazy after exam too because I had to squeeze so much in the last couple of weeks to get everything done. So I am okay. Don't repeat this to anybody because you guys are here. Oh wait a minute, I'm recording this. Everyone's gonna say, I'm real lenient on the due date for after exam too because there's just so much to do in such a short time. So you don't want to get behind, but I'm if you're a day or two late, I don't mark it late. Um, so any questions, comments, wants, needs, desires, concerns, complaints? Please, no complaints. I can't handle
For EE 1020
it.
people, we're done after the second
Yeah.
exam, right?
Oh yeah, that's right. And and it's amazing. For so many years, I had probably 5, 6 times as many students in 1030 as in 1040. And then they changed 1040 from civil engineers to where they have their own course. Um, and so now I think I only got one 1040 student this semester, but I have more 1020 students than I have 1030, 1040, and my SolidWorks combined. And you guys will all be done by at the second exam. I mean, you can stick around and do some more if you want, free learning, but I'm sure you got better things to do than work on MATLAB.
Did you say 1030 is also done after exam two? I
No,
thought
no,
1030.
no. Just 1020 is done after the exam. 1030,
Okay.
1030 will continue on with MATLAB. You learn some multi-dimensional arrays, some fancy plotting stuff, some symbolic calculations and stuff. And then my single 1040 student will go into Excel. And there's no final. The final exam for 1020 will be the second exam. See, I told you SolidWorks would be opening up.